What is silicone? Silicone, or abbreviated Si, is a nonmetal metalloid element that is the second most common in our Earth's crust, under or commonly with oxygen. Of course, being an atom, silicone consists of 3 subatomic particles. These are, numbered quite satisfyingly, 14 positively charged protons, 14 neutral neutrons, and 14 negative electrons. But before we continue into specificities like isotopes, let's step back and figure out what these building blocks are and how they affect silicone. In the case of the most common isotope, the nucleus of silicone consists of 28 subatomic particles. The first half of the particles is the positively charged proton. These have a relative mass of 1. Second is the neutron with no charge. Neutrons, when talking about an element in general, are hard to specify quantity, so I will just use the quantity of the later mentioned most common silicone isotope, Si28. Neutrons also have a mass of 1. After the nucleus, we only have one more area of the atom, the shells. In the shells are our final particle, electrons. As with other elements of the element, the amount of shells vary, but with silicone there are 3 shells. In shell 1, innermost to the nucleus, there are 2 negatively charged electrons. In shell 2, there are 8. And finally, in shell 3, there are 4 electrons. All of these electrons have a mass of 0.0005. That was a lot of information about dots and a dot. How do we simplify it? Well, we must use nucleide symbols, and more simply, notation. Beginning with the more digestible symbol, notation. Notation simply displays the element, or hyphened Si, for example, as well as the mass number. Mass numbers are the sum of the protons and neutrons. Next, in my opinion, the more helpful of the two, the nucleide symbol. Starting off, as you can immediately see, our 28 mass number and hyphened Si, but now you can also see 14, a bunch of little numbers, and it's now all in a tile form. The 14 is the number of protons in the isotope, describing how it relates to all other silicone isotopes. Next is the little numbers. If you remember well, you should recall exactly what these are, the electrons corresponding with their shells, in descending order from inner to outer. Finally is the number at the bottom. This is the mass of all subatomic particles combined. I added this as it is important information often found near the tile. To wrap up and max up the knowledge in this video, I will discuss the importance of silicone and information on it. Silicone, being one of the most common elements, is weirdly used by no organism. However, it can be found in quartz, clays, sand, and melted sand, also known as glass. Due to the sharp, crystalline nature of silica being SiO2, a common compound of silicon and oxygen, quarry workers and others who op around rocks and bricks develop silicus, a lung disease. This may sound familiar to you because another mineral of silicon, asbestos, does the same. Talking about crystalline structures, I find another form of silicon very interesting. Si04, or a silica tetrahedron, is a compound that resembles a 4-sided pyramid, with matching vertices. These structures that form in many minerals are surprisingly strong, especially when used together in complex formations. Most notably, the hexagon, the strongest 2D shape when used in groups. To wrap things off, I will show you the possibility of a silicon-based life form, in contrast to carbon. I call it a lithoid. It has 3 arms on each of its lower vertices, a diamond-shaped crystal on its upper vertice, and 2 little leg mineral things.